When the James Webb Space Telescope opened its golden eye, I believed we were finally going to answer old questions. Safe questions. Questions about early galaxies, ancient stars, and the first light that filled the universe after the Big Bang. That was the plan. That was what Webb was built for. To look back 13.5 billion years and show us the cosmic dawn. But the universe, as it always does, had other ideas. As I watched the first deep-field images arrive, I felt that familiar sense of awe. Galaxies layered on top of galaxies, light stretched and reddened by the expansion of space itself. Each faint smudge was a city of stars, burning when the universe was young. Yet something was wrong. These galaxies were too massive, too organized, too mature for the age they supposedly existed in. According to everything we know, they should not have been there. Not yet. The Big Bang Theory tells us that time itself began in a singular instant. No before, no earlier. Just a rapid expansion from a state of extreme density and temperature. Space, time, energy, all born together. For decades, that idea held firm. We could talk about fractions of a second after the Big Bang, but never before it. That boundary was absolute. Or at least, we thought it was. Webb changed that feeling almost immediately. As the infrared data stacked up, patterns began to emerge that shouldn't have survived the early chaos of the universe. Light signatures hinted at structures forming far faster than simulations allowed. Even more unsettling, some signals appeared older than the oldest light we expected to see. Not older by a few million years. Older in a way that challenged the starting line itself. I remember the moment a colleague said it quietly, almost jokingly, as if saying it out loud might break something. What if this light isn't from after the Big Bang? What if it's from before? That sentence lingered in my head longer than it should have. The James Webb Space Telescope doesn't see visible light the way our eyes do. It sees heat. It sees stretched photons that have traveled for billions of years, warped by cosmic expansion. Webb is essentially a time machine, peering so far back that it approaches the limits of reality itself. And now, it seemed to be pressing against a wall we believed was impenetrable. Some of the earliest galaxies Webb observed showed chemical complexity that implied generations of stars had already lived and died. Heavy elements, forged in stellar cores, were present far too soon. This suggested not just early star formation, but an entire hidden history before the moment we thought everything began. If these observations hold, then the universe didn't emerge from nothing into something. It emerged from something else. I felt a strange mix of excitement and dread. Because rewriting cosmic history is thrilling, but it also means admitting that we may have misunderstood the most fundamental truth of existence. Time may not have started with the Big Bang. The Big Bang may have been a transition, not a beginning. There are theories that suddenly feel less theoretical. Cyclic universes, where one cosmos collapses and gives birth to another. A bouncing universe, where time stretches infinitely backward, compresses, and expands again. Even ideas that suggest our universe emerged from a pre-existing quantum state, where reality never truly began, it simply changed form. Webb wasn't designed to prove these ideas, but it may have stumbled into them anyway. As I scroll through the data, what chills me isn't just what we're seeing. It's what we're not. There is no clean edge, no clear line that says, this is the beginning. Instead, there is continuity. A smoothness where violence and creation should have erased everything. If something existed before the Big Bang, then causality itself might extend beyond time as we know it. The universe may have a memory, and James Webb may have just uncovered its earliest whisper. And that leads to the most unsettling possibility of all. If there was a before, then there may also be an after. And our universe may not be the first chapter in the story of reality. When I look at these signals again, I feel the weight of what they imply settling deeper into my chest. Because light is honest. Light doesn't lie. It carries the history of where it's been, how long it's traveled, and what it has passed through. And the light Webb is detecting is telling a story that contradicts the one we've been telling ourselves for nearly a century. The Big Bang was supposed to be opaque at first. In the earliest moments, the universe was so hot and dense that light could not move freely. Photons were trapped in a glowing fog of particles. It wasn't until roughly 380,000 years later that the universe cooled enough for light to escape, creating what we call the cosmic microwave background. That radiation is the oldest light we should ever be able to observe. Everything beyond it should be forever hidden. And yet, Webb is seeing structured light sources that appear to predate the expected timeline of cosmic clarity. These aren't random artifacts. They aren't instrument errors that can be easily dismissed. The signals repeat. They appear across different observations, different regions of the sky, different calibration runs. The universe is whispering the same message from multiple directions, and it's disturbingly consistent. Some of these light signatures suggest large-scale order, not the chaotic aftermath of a violent birth, but something closer to continuity, as if matter had already learned how to organize itself long before the clock officially started ticking. That idea alone bends the mind, because order requires time. Evolution requires time. Cause and effect require time. So what happens when time itself may not be confined to a single beginning? I remember reading about early alternative models years ago, theories most people treated as intellectual curiosities rather than serious contenders. The conformal cyclic universe, eternal inflation, quantum loop gravity suggesting a universe that contracts before it expands. Back then, they felt distant, abstract, safely unprovable. Now, Webb has dragged them out of the shadows and placed them under the harsh light of observation. One explanation suggests that what we call the Big Bang wasn't the creation of everything, but the reshaping of something that already existed. A phase change, like ice melting into water. The molecules don't disappear. They reorganize. In that view, the universe before the Big Bang may have left subtle fingerprints in the radiation we're now detecting. And those fingerprints may be exactly what Webb is seeing. There's another possibility that keeps me awake at night. What if the laws of physics themselves were different before the Big Bang? What if constants we treat as fundamental, time, entropy, even causality, behaved in ways we can't yet imagine? Webb's observations might not just be revealing older light. They might be revealing a different rulebook entirely. I feel a chill when I realize what this would mean for our place in the cosmos. If the universe existed before its own birth, then existence is far more resilient than we thought. Reality doesn't blink in and out. It flows. It transforms. And it doesn't ask for permission from our theories. Some researchers argue that we're misinterpreting the data, that these galaxies only appear older due to unknown processes in early star formation. That dark matter behaved differently. That cosmic expansion wasn't as uniform as we assume. And those are fair arguments. Science demands skepticism. But even the skeptics admit something unsettling. Webb has pushed us into a corner where our old models strain to survive. I imagine the universe just before the Big Bang. Not empty, not silent, but compressed, waiting. A cosmic inhale before the greatest exhale imaginable. And if that's true, then the Big Bang wasn't the start of the story. It was the loudest chapter break. What terrifies me most is how close we are to understanding this. The answers aren't hidden in fantasy or speculation anymore. They're buried in real photons, real measurements, real data streaming down from a telescope parked a million miles from Earth, quietly watching the universe confess its secrets. And we've only just begun to listen. There is a moment in every discovery when excitement turns into something heavier. A moment when curiosity gives way to responsibility. That's where I am now. Because if the universe truly existed before the Big Bang, then it may carry scars. And scars mean memory. The data from James Webb isn't just challenging timelines. It's challenging the idea that the universe resets itself. In the standard picture, the Big Bang wipes the slate clean. Whatever came before is erased, unreachable, causally disconnected. But what Webb is hinting at feels different. It feels like continuity, like a story that never truly stopped being written. One of the most disturbing clues lies in symmetry. The early universe should have been wildly uneven, filled with violent fluctuations. Yet Webb is detecting surprising uniformity in regions that had no time to communicate with each other. These structures appear coordinated, as if they inherited information from an earlier state. That kind of coordination should be impossible unless something carried it forward. Some cosmologists refer to this as cosmic memory, the idea that certain patterns can survive transitions between universes encoded not in matter, but in geometry itself. Space remembering how it once behaved. Time remembering which direction it preferred to flow. If that's true, then the Big Bang didn't erase the past. It preserved it in whispers. I find myself thinking about entropy, the arrow of time, the relentless march from order to disorder. One of the deepest mysteries in physics is why the universe began in such a low entropy state, why it was so incredibly ordered at the start. That question has haunted scientists for decades. Now, Webb may be offering a terrifying answer. Maybe it didn't start that way. Maybe it ended that way. In some models, the universe before ours was old, vast, exhausted, matter diluted, energy stretched thin, and when it reached a certain threshold, it transformed, collapsed not into destruction, but into rebirth. In that process, entropy could have been reset, not erased, but reconfigured. Enough structure surviving to guide what came next. That would explain why the early universe appears suspiciously prepared, why galaxies form so fast, why the cosmos seems to know what it's doing from the very beginning. I feel small when I consider this, because it means we are not living near the start of time. We are living in the middle of something far older than we can comprehend. A cosmic cycle that may have repeated countless times before we ever looked up at the stars. James Webb is uniquely positioned to sense this. Its infrared vision allows it to detect subtle distortions in light caused by space-time itself. Tiny irregularities that could hint at pre-Big Bang geometry. And some of those distortions are there. Barely, but enough to make physicists pause. The most chilling part is that this isn't just about the past. If the universe remembers, it may also predict. The same processes that birthed our cosmos could one day end it. Not in fire or darkness, but in transformation. Another transition. Another inhale. I imagine future observers, in some distant universe, looking back at the remnants of ours, seeing faint echoes in their data, wondering if they are alone in time, just as we are now. And suddenly, the question isn't what happened before the Big Bang. The question is how many times this has already happened. Because if the universe remembers, then James Webb hasn't just looked back in time. It has looked into a pattern, one that suggests reality itself may be eternal, cycling through beginnings that are not beginnings at all. And if that's true, then our universe is not special because it exists. It's special because it remembers enough to continue.